So, rocks are ubiquitously found in the crust of the earth. There is a lot of diversity in the rocks, and is it echoing? Sound ಬರ್ತಾ ಇದೆ? Sound. Okay, it's all right.
Audible,
is it audible? Am I audible to all of you?
Yeah.
Yes, sir.
Yes, sir.
It's audible.
Yes, sir. Yes, sir.
Yes, sir. It's audible, sir. Sir, it would be better if you put on the earphone, sir.
Okay. So, rocks are ubiquitously found on the surface of the earth and also in the interior of the earth. If you take the entire the crust of the earth, it is made up of solid rocks only, and there is a lot of diversity in these rocks. In the sense, these rocks are utilized to some extent by the mankind. See, if you go back to 40 years back, we were not aware of what polished granite is, what type of granite we have to put into our kitchen, and how limestone is used in the industry, etc., etc. We were not aware of that one. So gradually, innovations made us to get into these things. So today, more and more innovations have come, and some of the only few of the rock types are being utilized as a industrial rock. So industry is using them, right? So still more scope is there for innovations in this field, and people can come out with new innovations for utilizing the different types of the rock. So before that, yesterday itself, I defined what is a mineral. So mineral is an inorganic substance having definite chemical composition and regular internal atomic structure. Okay, so minerals are valuable resources for life support activities of the human population. So minerals are naturally occurring inorganic substances. And we know that minerals are formed from various processes and source material. Then what is a rock? By definition, rock is an aggregate of minerals. There are scores of rocks in nature. Only few of them find their utility in the list of industrial uses. Hence, they are bracketed under the name industrial rocks. So, I think by your fundamental studies, all of you know there are three kinds of rocks that occur in nature. We have classified them into igneous rock, sedimentary or secondary rocks, and metamorphic rocks. With many subclassifications are there, into which I am not going in detail. So, igneous rocks means they are primary rocks. They are formed directly from what is known as magma. Magma is a heterogeneous molten silicate melt. Okay, so these things are found in the region of the upper mantle. That means wherever you are now, if you go down below 35 kilometers in the continental crust, you will enter into a region called mantle, where temperature and pressure are so much high that all the material there will be nearer to their melting point. They are very nearer to their melting point. So that means they are neither liquid nor solid. That is the condition there. From there, the igneous rocks form. Okay, and when these rocks they are exposed on the surface of the earth, they will be subjected to the process of what is known as weathering. Weathering means disintegration of the rock. So disintegration of the rock. After the disintegration of the rock means what happens? It gets transported. So layer by layer, rock is formed again in the basins, in the ocean basins. Okay, they are called as sedimentary rocks because they are derived from sediments. So metamorphic rocks means whether it is an igneous rock or a sedimentary rock or a metamorphic rock itself, if you take them down below the subsurface, it will be subjected to pressure, temperature, and fluid activity. As a result, original rock will get recrystallized. So it becomes a metamorphic rock. Metamorphism means change. Transformation is metamorphism. That is how these kinds of rocks are formed in nature. Okay, all the rocks, there is a lot of diversity in the rock types. Okay, all the rocks that occur in nature, they are not useful to industries. Only a few of them are used in industry. Okay, I told you, no, if you go back to 40 years, you don't find the utility of these things by humankind. But later on, innovation has made us to use all these things in our daily life also. So, what is the meaning of this one means? Maybe research in this field in future may throw light on the rocks that occur in nature and not utilized in the industry. That's what is going to happen. So, the group of rocks and minerals used in industry or in the engineering enterprises, they may be listed. Like for building, we need rock. For roofing material, we need rock. Okay, including the crushed stones. For hydraulic cements, we need rock. For gravels and sands, rock is the source. Gypsum, anhydrite, limestone, dolomite, magnesite, mineral wool, asphalts, and bitumens, clay materials. Yesterday, in my previous lecture, I have discussed about some of these things. Okay, anyhow, in this lecture, I will be concentrating more on the limestone, how it is used in the different types of industries, and the dimensional stones, that means decorative stones, building stones, and also on different kinds of sands. That's most important. There are various kinds of sands available in nature that are being used in the industry. So if you come to this utility of limestone in industries, the element calcium has been the basis of formation of all limestones, because the composition of limestone is calcium carbonate. It will have a mineral calcite. Okay, limestones, marls, and dolomites. Dolomites is calcium magnesium carbonate. So calcium, this creates the beauty of marbles and imparts valuable technical and mineralogical properties to each one of these calcium-based minerals occurring in nature. The earth crust contains about 3.4% of calcium and 2% of magnesium by weight. These two elements, they have linked the loss of calcium dispersion with remarkable properties of calcium atom itself, along with an even number of the electrons and with a perfect stability of the structural setup. After their emplacement in the crust, these calcium atoms, they have taken a very complicated migration. That's why they are found in different spheres of the earth. In the earlier geological period, what is the meaning of this geological period? Here, I would like to give you some information regarding the origin of the solar system itself. So, this origin of the solar system, it took place around 4,600 million years ago. Okay, it is believed. So then later different planets came into existence. One such planet is the Earth. So on the Earth, so far, the oldest rock that is dated is around 4,000 million years, approximately. Okay, from that period onwards till today, what is happening to the Earth, especially in the initial stage of the formation of the Earth, Mother Earth has suffered a lot. Okay, there was bombardment of meteorites onto the surface of the earth on one side. On the other side, there was volcanic eruptions. As a result of these volcanic eruptions, all these things happened between 570 million years up to around 4,000 million years. During that period of time in the history of the earth, it was a turmoil period for the Mother Earth. It has survived a lot of it. Okay. So there was a number of volcanic eruptions that poured out large masses of carbon dioxide to the surface of the earth during that period. Following the release of an enormous amount of carbon dioxide, calcium yielded strong and stable compounds. During the period of the surplus atmosphere of carbon dioxide, calcium carbonate had been transported by water, and with the loss of carbon dioxide, it was deposited in the form of a white crystalline powdery mass. So it is thus presumed that the thick beds of limestones have been formed by this process. That is how the limestone is formed. Okay, whatever the calcium and other things they are carried by the river system and deposited in the ocean basins, layer by layer. Okay, resulting in the formation of the limestone. That's why limestone is called an secondary rock or a sedimentary rock. It is completely made up of mineral like calcite,
ఏమంటారండి?
calcium carbonate.
వస్తున్నా.
And another thing happened to this limestone. What happened? These limestones, they were subjected to deformation. Okay, so by orogenic and epirogenic activities of the earth crust. See, orogenic means, I think yesterday you might have seen the TV news. They were telling Himalaya has raised by around 1 meter height from 1970 till today. That means it is because of the orogenic activity. What is the meaning of it? Means our Indian plate is going against the Tibetan plate. They are hitting each other. Okay, as a result of this collision, there is rise of the Himalayas. Okay, that type of orogeny has taken place in the past. Epirogeny means on the surface of the earth, formation of the basins, elevated range, etc. All these activities has witnessed in the past. Okay, as a result of these activities, what happened? Some of the limestones, they were taken to the depth. They were taken to the depth means they have been subjected to pressure and temperature conditions. Okay, once you say the depth factor means as you go down the subsurface, pressure increases, temperature increases. When you take the limestone to that depth, what happens to it? Mineral grains will get recrystallized. Depth. Because of the increase in temperature and because of the fluid activity, the subsurface of the earth, limestone gets recrystallized and it becomes a marble. So that is a metamorphic.
మరి సవేరా కల్పించింది చేద్దామా?
Please, I think some of you have to mute the mic. I'm hearing something.
Srinivas sir, please mute your mic.
Please mute your mic. I'm not able to deliver things. So what happened? These limestones, they were taken to greater depth because of the increase in temperature and pressure and also fluid activity. Limestones changed to marble. A sedimentary rock changed to a metamorphic rock. That is considered as most important building material today. Calcite, which is the predominating mineral ingredient in all the limestone formations, is formed in large masses of recrystallization of limestone. Recrystallization of limestone means is the formation of the marble. You can see the limestone, how it is formed in layer by layer. Okay, this is a specimen of the limestone, and after mining, they will cut into different sizes and they will utilize for many of the construction purpose. You can see here. See, marble, it is a recrystallized limestone. Okay, this is a marble mine from where it is being, marble is removed, it is exploited, so then it is polished and put for various construction purpose. And you can see here, this is the marble under microscope. Okay, these are all the calcite grains that you can see under the microscope. Next is cement grade and flux grade limestones. Cement grade limestones contain 4 essential chemical elements such as calcium, silicon, iron, and aluminum. The other elements present, of which the number is not limited, are unessential and their quantities are relatively small. Although both iron and aluminum are present in the raw materials, only one of these is actually required. For selecting the cement grade limestones and other essential raw materials for the manufacture of Portland cement, consideration should be given to the following points. On the basis of composition, the requirements for one or more raw material is to be used in producing a clinker. The essential elements must be present within the desired limit, and the non-essential elements must not be present in undesirable quantity. The raw materials should possess a fair degree of uniformity. The physical properties which are essential, they are the resistance to grinding, ungrindability, and others is the homogeneity. That means sample should be a homogeneous one without any other compositions within the limestone. Uniform hardness throughout the process of grinding is insisted at the time of pulverization of the materials. That means limestone should have a uniform hardness, okay, throughout the process of grinding. Otherwise, variation in hardness will create problems. So during the exploitation of limestones and clays in a quarry, it should be taken into consideration that stones that are blasted should shatter very easily without any difficulty. Okay, if we are not able to blast it very easily, means hardness plays a very important. That means variable hardness is there in such material. So even if you take it out, it will pose problem during the pulverization. So that has to be taken care. In case of a clay deposit, it is to be used in a wet process plant. It should not contain undesirable quantity of colloidal, that means small solid particles that are suspended in a fluid phase material. The British standard specification for the cement grade limestone is that it should not contain more than 2.5% of magnesia. The CaO should not be less than 42% and SiO2 not more than 14% to 15%. So this standard has to be maintained. When silica is present as free quartz or chert, see, free quartz means it is SiO2. Chert means it is also a SiO2, but it is a precipitated material. So when silica is present as a free quartz in limestone or as a chert in limestone, the ultimate pulverizing operation becomes expensive. That has to be taken care. On the other hand, when silica occurs as silicates, that means it gets into some silicate minerals, it is less objectionable. So that will not pose much problem. If it is in the form of an oxide, then it will be a problem. When silicate minerals occur with aluminum, it is a desirable ingredient known as clay. So it is a part of it, clay. It becomes a clay mineral, which is required in cement grade limestones in a limited quantity, particularly in Portland cement manufacture. If the P2O5 content of the limestone is more than 1%, it is not desirable. Iron in the form of oxide or carbonate, iron oxide or iron carbonate or iron silicate in limited quantities acts as a flux. Sulfur in the form of sulfide or sulfate is undesirable, as they may lead to the formation of sulfo-aluminate in the finished product. Iron sulfide should not be more than 2%. So these are all the specifications that is very much required in cement industry. When the limestones are argillaceous, when we use the term argillaceous means it is clay rich. It is a clay rich, magnesium, aluminum, silicate, like that. When the limestones are argillaceous in character, it becomes easier to grind the material. In the final ground material, before firing, the calcium carbonate content may be 75%, whereas SiO2 plus Al2O3 plus Fe2O3 should be 20%. MgO plus alkalis, sodium and potassium, should be around 5%. So this is the cement grade limestone, you can see here. So it will be crushed to these different sizes, and finally it will be made into a powder like this. So this is the ultimate raw material that one has to prepare for a cement grade limestone. Next is flux grade limestone. So for metallurgical purposes, limestones are required in blast furnace operations. Why? In order to flux out the silica and alumina present in the iron ore. These ingredients are accumulated at the bottom of the blast furnace and are tapped periodically as slags. So slag will be there. So it is therefore necessary that these constituents should be low in amount in the flux grade limestone. The CaO should be at least 45%, but it is preferable to have CaO content between 47 and 50%. High grade limestones sometimes contain as high as 50% of CaO, but such deposits are not very extensive. The P2O5 should not exceed 0.01% at the time of manufacturing low phosphorus iron. But for the manufacture of basic iron, 1.5% P2O5 content in the limestone is necessary. Sulfur should not exceed 0.5%. So these are all the conditions for a flux grade cement. It has been found that ordinarily sulfur is low in most of the limestones, unless it contains a good amount of a mineral called pyrite. Pyrite is a iron sulfide mineral. Sometimes what happens in the limestone area, because of the injections of some huge granitic bodies or other things, fractures will develop. Along those fractures, this pyrite mineralization takes place. That means it is a limestone rock, but within that, the fractures will be filled with the mineral pyrite. So it should be less in limestone. The limestones used in the steel melting operations should be purer than the blast furnace variety. But P2O5 and the sulfur should be as low as possible. That means it should be free from the pyrite content. Specification of limestones required for steel melting. CaO should be between 47.5% to 48.8%. SiO2 should be less, 4.4 to 3.8. That means it should be free from the mineral quartz. Al2O3 between 1.8% and 1%. MgO between 3.5% and 3.8% with very low phosphorus. So this is the flux grade cement that is prepared for steel melting industry. Limestones for hydraulic lime manufacture. Preferably argillaceous limestones. I told you, no, argillaceous limestones means clay-rich limestones. They are required for this purpose, containing at least 18 to 20% of clay minerals for the manufacture of hydraulic lime. The limestones for this purpose should be fairly hard and massive in texture. In the sense, texture means arrangement of the individual mineral grains. Why this should be there? This is in order to withstand any tendency to crushing in the lime kiln. The material should be reduced in size to be less than 7 centimeters. So that is the specification for hydraulic lime manufacture. Some of the raw materials may be lost due to over or under burning in the kilns, but it has been ascertained that 2 tons of limestone, it can produce about 1 ton of lime. Water is added to the finished product in order to convert it to quick lime or soaked lime. Carbon dioxide gas, it is the chief waste product of a commercial lime plant, and it comprises about half of the raw materials. Carbon dioxide can be easily recovered. It can be purified and compressed into a cylinder in liquid form, and also it can be solidified. Lime has 3 principal commercial markets, where one in building construction, lime is used. In industrial applications, lime is used. In agriculture, this lime is used. So this is the flow chart to show lime manufacturing process drawn from a book. That is limestone. This is the raw material. It will be put into crusher. It will be ground in the crusher. Ground limestone will be put into kiln, okay, to produce quick lime in the hydrator. Then it becomes a hydrated lime. So limestone should be 100 to 200 millimeter in size. So then after crushing, it should become 10 to 20 millimeter. Then it will be burnt. It becomes a burnt limestone. So 10 degrees centigrade per minute at up to 1200 degrees centigrade for 5 hours, it has to be done. After burning and melting, you see the stages here. Then you have to do the hydration with a rotation of 300 RPM for 30 minutes. Then drying for 24 hours and grinding. Finally, you will produce NHL. What is this? Natural hydraulic lime, used for lime plastering. That is how it is done. So lime for building construction and paper industry. So here, this lime, here MgO content should be low and silica content may be about 10%. In industrial utilization of lime, and particularly for chemical processing, including water purification, treatment of waste materials, and sewage accumulations, the lime merchants are fortunate enough to have a steady market for fairly large tonnage. Lime is used in the liquor. So lime is also a product that is used in the liquor, because lime is said to be slower absorption of alcohol, and lime reduces the impact of alcohol on the liver too. And for cooking racks it is used. And also for wood pulp manufacture, lime is used. As fillers in paper and in this manufacture, lime is used. But argillaceous lime, that means clay-rich lime, is not suitable, and purer quality of lime is preferred. About 1 ton of lime is required for 3.5 tons of finished paper. The paper industry consumes considerable amount of lime, and it is also one of the largest manufacturers of lime. Much of the lime used in the processing of paper is recoverable as calcium carbonate sludge, which can be used for the manufacture of lime. Either quick lime or hydrated lime can be used, but usually quick lime is preferred. High calcium limestones are usually utilized in paper as well as in glass manufacture. In glass manufacture, high calcium limestones are required for fabricating bottles and window glasses. Organic matter should not exceed 0.3% because there are limestones called fossiliferous limestones. They do have organic matter in them. Okay, that should not exceed 0.3%. That means while selection itself, you have to make very careful selection. The material should be ground between 200 and 100 mesh. Specification of limestones for the manufacture of colorless glass are that they should contain 55.2% of calcium oxide, preferably 98.5% of CaCO3. Fe2O3 should be as low as 0.035%. Manganese, lead, sulfur, P2O5 when present should not exceed 0.1% each. So these are all the lime stones that are used for building construction. So this is the surface mining for limestone. A bench mining has been done here, and the same limestone is used for construction of the buildings. So this is the lime that is used in the paper industry. So limestones are also used for sugar industry. So that means lime is used for removing the impurities from the cane juices and also for precipitating sugar from impurities. In association with sugar, lime forms insoluble salts, which are split by the action of carbon dioxide, which is manufactured in the sugar factory by burning the limestones. It should contain at least 90% CaCO3, calcium carbonate. MgO should not be more than 3%. So here you see the burnt limestone for sugar industry. Limestones for alkali manufacture. For the manufacture of soda ash, high calcium limestones are absolutely necessary. For each ton of soda ash, 1 to 1.25 tons of limestones are required. Limestones are reduced to 2 to 10 centimeter in size. MgO should not exceed more than 6%. The high calcium limestone should be as pure as possible. The total Fe2O3, Al2O3, SiO2 should not be more than 0.3%. Okay, this is done with the help of leaf blank process. The calcium carbonate content should be 96%. Limestones containing very little clay matters are used for the manufacture of NaOH. Available lime should be at least 85% and MgO should not be more than 3%. So here you can see alkali activated limestones. They are processed. Limestones are used in the manufacture of bleaching powder. So high calcium limestones with very little clay materials are required for the manufacture of bleaching powder. Calcium carbonate content should be more than 96% for this bleaching powder preparation. MgO less than 1.5%, SiO2 around 2%, Al2O3 plus Fe2O3 should not be more than 1.1%. The limestones after burning should give a fat lime which will form powdery mass. After slacking for half an hour, it gives a quantity of slacked lime about 3 times that of the original lime. The lime should be very fine in texture and should be porous so as to allow the permeation of gases. So CaO 54%, SiO2 1% to 3%, P2O5 should be very less, 0.01% to 0.05%, MgO 0.05%, Fe2O3 1%. The impurities should be as low as possible for the preparation of the bleaching powder. So this is how the bleaching powder production is done. So limestone, calcium carbonate is a raw material, it is used. So then it will be dissociated into calcium oxide and carbon dioxide, treated with water, and finally you will see the end product, that is a powder, bleaching powder. So limestone is also used in water treatment. Quick lime or hydrated lime used for water treatment. For the purpose of softening of hard water, the hydrated lime should not contain less than 68.1% of available lime, and you should be free from silt and other impurities. The quick lime should contain more than 90% available lime. Limestones, they are also used in the filter beds for purifying drinking water. The limestone should be tough enough to withstand weathering. So weathering means either it can be a physical weathering or a chemical weathering. Physical weathering means disintegration through physical process. Chemical weathering means interaction with some agents like wind, water, etc. and disintegration, then transportation. Okay, so that means the limestone should be tough enough to withstand weathering means even if you subject them to any of the changes, it should remain. It should not get disintegrated. That is the meaning of it. And it should be free from clay, pyrite, and other impurities. So such type of limestone is good for water treatment. So I can see here, this is the open cast mine of the limestone, where they have done the bench mining and have recovered the limestone. And this is how the calcium water inflow will be there. Calcium hydroxide will form. Then water saturated with calcium hydroxide will run through this pipe, then get this precipitated in the reactor, and finally it has to pass through a gravel filter, and then the water outflow will be there. So that means how the alkalinity reduction with slaked lime, the treatment of water with the lime can be done. So limestone is also used in the tannery industry. For crude dressing, high calcium limestones are used. Magnesia is regarded as a not feasible material, it is objectionable there. Fe2O3 and Al2O3 should be as low as possible for the limestones that is used in the tannery industry. Limestones are also used in the textile industry. Lime should be as pure as possible. CO 94%, MgO 3%, Fe2O3 plus Al2O3 2%, and SiO2 insoluble matter should not be more than 2.5%. The maximum permissible percentage of carbon dioxide should be 3 in hydrated lime and 5 in quick. Lime containing readily soluble iron and a good amount of non-hydrated magnesia should not be used in the textile industry. So limestone in chemical industries, various grades of limes are used as neutralizing agents in many chemical processes, particularly in the manufacture of soaps, insecticides, glues, gelatin, starch, and phenol. The lime should be free from clay materials, silica, alumina, and iron oxide. Silica is quartz. Limestone should be free from the clay material. It should be free from quartz. It should be free from alumina content, and it should be free from iron oxides, minerals like magnetite, hematite, etc. For the manufacture of various chemical reagents such as chromates, dichromates, permanganates, etc., high calcium limestones are preferred. So limestones is also used in lithographic printings, very fine grained limestones and compact limestones with a uniform texture, with a blocks of uniform texture. They are utilized for lithographic printing. That means the surface of the stone should be free from crystalline outlines, siliceous specks. That means it should not contain quartz grains here and there. And any other veins, pyrite veins or quartz veins should not be there in such kind of limestone where it is used for the lithographic printing. The fracture should be a glassy surface, free from grains, and it should be conchoidal, concentric. Conchoidal means concentric fracture should be there. Al2O3 plus Fe2O3 plus SiO2 should not exceed 5%. The stone fragments should be dissolved completely in HNO3 with an insignificant residue. So if these conditions, it will serve as a good lithographic printing. Litho means rock, lithographic. So on the rock you will be printing. See, you see here, this is the lithographic printed material. So these are all the limestones on which printing has been done. So that's why, since it is on a rock, it is called litho. Litho means rock. Graphy means pictures, figures. That's used here. Limestones also used in agriculture. High magnesium limestones are often used for agriculture purpose. High magnesium limestone means it should be dolomitic limestone. That means it should be calcium magnesium carbonate. Because the magnesium oxide and magnesium carbonates have relatively greater neutralizing value for acidic soils than the corresponding calcium minerals. That is the reason it is used in the agriculture. Magnesium limestone also supplies the element magnesium, which is a very essential plant food, and it may be used as a fertilizer also. It is extensively used in tobacco cultivation. This limestone is used in tobacco cultivation and also in fruit growing industries. However, a use of agricultural lime is very limited. It is sometimes mixed with organic manure in order to preserve the nitrogen, and it is used for whitewashing of agricultural farms and stables. So coming to the areas where these limestone deposits are found in our country, most of the states, they produce limestones. They have limestone deposit from Karnataka, Madhya Pradesh, Rajasthan, Andhra Pradesh, Tamil Nadu, Orissa, Gujarat, Meghalaya, northeastern region, and Assam, Bihar, Himachal Pradesh, Punjab, Haryana, Jammu and Kashmir, Uttar Pradesh, West Bengal, and Kerala. In all these states, limestone deposits are found. So let us discuss something about limestone deposits of the Karnataka state. So here, extensive deposits of crystalline limestone is available, ranging from high calcium types containing less than 3% of magnesium to dolomitic type, that is calcium magnesium carbonate type, containing 10 to 18% of MgO. Limestone deposits form part of the Darwar system. Geologically, we use the term Darwar system for the stable part of the crust in this southern part of India. So they occur in Darwar, Shivamogga, and Gadag, Chittadurga, what we call as schist belts. That means they are made up of metamorphic rock called schist. They are linear in nature. There, along with them, this limestone occurs. Limestones are also found in North Karnataka at a place called Kaladgi, and also in Andhra Pradesh, Kadapas, and in northern Karnataka, in the Bhima area. Bhima river flows. So surrounding that area of the Bhima river flow, you have deposits of the limestone. So large quantities of crystalline limestone comprising siliceous, argillaceous, that means siliceous is silica based, argillaceous is clay, and high calcium types are available not only in many areas of Karnataka state, but also in the districts of Bijapur, Belgaum, and North Canara. Deposits of limestones are there. Even in and around Mysore, we have limestone deposits. We go about 6 kilometers from Mysore. There is a place called Bettada Beedu, where you have a mine of limestone, but it is mainly dolomitic limestone. It contains a lot of calcium, magnesium, carbonate. Next is building stones and crushed stones. In recent days, building, structural and road metals and paving stones have created a huge demand for the mineral and rock-based materials of inorganic origin. Usually, all types of stones which are hard, tough, which can withstand weathering, that means disintegration to natural processes, and abrasion, they are preferred. They are particularly preferred. Crushed stones are used as concrete materials with cement and lime. Building materials are essentially composed of rocks and mineral products. Solid blocks of various types of rocks and also fragmented rocks are usually extensively used for building houses, hutments, and bungalows. All types of rocks, particularly granite rocks or gneissic rocks. I think you might have seen these rocks. They are ubiquitously found on the crust of the earth. Okay, so there is no depth of these rocks because our continental crust thickness is 35 kilometers. So we are just exploring on the skin of the crust. Okay, remaining things needs to be explored. So all types of rocks, particularly granite, gneisses, crystalline schists, massive and compact sandstones. Sandstones means they are completely made up of quartz grains. See, Red Fort of our country is built by red sandstone. And limestones, dolomites, slates. Slates is a very argillaceous material, clay material, then subjected to changes in temperature and pressure and fluid activity, and it has become a metamorphic rock. Shale is a sedimentary rock. If you subject it to high temperature, pressure, and fluid activity, it becomes a slate. Chondrites. These rocks are found around Kerala. And compact laterites. Laterites, if you go by any coastal area, you will see the cap of the laterites. So lateritic soil, laterites are used everywhere. They are used as substitutes for bricks. These rocks are used directly with some amount of trimming. What the requirement is there for this one is just you trim the surface and measure the dimensions, and you can polish it, polish the uneven surfaces and use it directly. So certain physical properties are taken into consideration for utilization of rocks of various types, especially as building and roofing materials. These properties are durability. Say building material and roofing materials, why we have to take caution means they should be able to withstand disasters. For example, if there's an earthquake in the area, if you use very low quality material and if you want to construct a building means, definitely it is going to collapse. So nowadays, that's why Government of India has come out with a law, what is known as BCC. That means Building Construction Code. So that has to be followed because that saves you from the earthquake if you use the material that is specified by them for whether roofing purpose or construction building. So that means the most important properties are durability. They should be able to withstand everyday wear and tear. Hardness, hard material should be used. Toughness should be there. Strength should be there. And how easily they can be processed and quarried without serious waste. That is also a very important aspect. Most of the rocks are used as untreated. They are directly used. And in a crude state, directly from the quarries, some of the rocks are used. The costly stones are cut and dressed and sold in the market as dimension stones or ornamental stones. Okay, many of the people nowadays, they have the fashion to put ornamental stones to their house for facelift and for flooring, and for kitchen, etc., etc. So when these materials, yes, somebody has to mute the mic. I'm hearing some other voice. So when the material are broken into pieces, they are called crushed stones. They are used for different purpose. The common rocks used as building and roofing materials are granite, granite gneiss, and some other compact and crystalline igneous rocks, limestones, marbles, slates, fine-grained compact sandstones, steatite or soapstone. All these things are used. Steatite or soapstone is a very important rock. It has a historic background. Steatite is a mineral. It is a magnesium hydroxide and the hardness is number 1. That means you can scratch with your fingernail. Very difficulty. With a pen knife with difficulty you can scratch. With a fingernail you can scratch with difficulty. With a pen knife you can scratch very easily. This steatite or soapstone. Most of the earlier monuments, like for example in Karnataka we have Belur and Halebid architecture. That is carved out of this steatite or soapstone. Or in Jabalpur near in Madhya Pradesh, you have Khajuraho temple and other things. They are carved out of this material. Why they have used this material? That was locally available. And transportation, they have saved it. And these materials can be used for carving in a very great way, and very good architecture has come up. So it represents our ancient skill also. So almost all these type of rocks are required for more than one purpose. Granite is for one purpose. Marbles are used for some other purpose. Steatite or soapstone for some other purpose. Like that. These are all common rocks, but very useful for construction purpose. Dimension stones also used for other structural purpose, such as construction of bridge pillars, abutments, fences, retaining walls, monuments. Okay, so we have a beautiful Taj Mahal. It is a monument made out of marble. Okay, then Red Fort of Delhi, constructed out of old red sandstones, red color sandstones. Paving stones can be made, switchboards, etc., etc. So dimension stones, they have multi-uses. Very few rock materials satisfy the requirements for dimension stones due to conditions of easy exploitation from quarries, color of the materials and workability. All these things, they play a very important role here. Porosity and permeability, they are also taken into consideration. Porosity and permeability affect the coefficients of expansion and contraction of rocky material. Some of the modern architects prefer very much uneven and rough texture on the outer walls as an emblem of modern decoration. Granites and other similar types of rocks can resist climatic weathering. This is most important. So everyday wear and tear is also taken into consideration. So since granite is a very hard material, so it can withstand climatic changes. And also some of the hard and compact sedimentary rock types like sandstone. That's why our fort, the Delhi Red Fort or Qutub Minar, they are staying for so many years because of the type of the rock that they have used. However, fine-grained sandstones with silica cementing material are considered good. Okay, silica cementing material means here fine-grained, rock is fine-grained, sandstone means it contains quartz grains. That means in between the quartz grains, we will have a cementing material. That cementing material should be siliceous in nature. That means it is a quartz material. Okay, so then such sandstones are very hard. Limestones, which are close textured, of low porosity and insignificant permeability, are considered as good building materials. Resistance to heat and fire is also very high in fine textured materials. Usually, granitic rocks are also preferred as tombstones, along with cyanides, monzonites, diorites, dolerites, and the porphyrites, rhyolites, and andesites. These are all the different types of rocks. So those who have studied geology, I think they may be able to understand the names of these rocks. See, dolerite, I will tell you, dolerite is your kitchen. It is in your kitchen. It is a black granite. In the commercial market, it is considered as a black granite, but the scientific name is dolerite. Okay. Rarely, albestor, amazonite, greenstones, and compact mica sheets are used as building materials. Okay. So many of the tombstones are built with this. See, dolerite, this black granite, it goes to Japan more. A lot of export is there to Japan because it is used as a tombstone there. Whoever dies there, their tombstone will be made out of this dolerite only. They think that it is good for them. So these are all some of the images for building stones. You can see here the limestone and the construction of a building, and roofing stones. So top roofs are put with these type of stones. Okay, these are usually either limestone or slates. It should be slates or limestone. Or Kadapa rock, we call it as now here in south, it is slate only. And decorative stones. See here, these are all the different decorative stones that are available in nature. You can decorate the way you want using all these type of different decorative stones. Tombstone of granite. See, this is a granite quarry where blocks of granite are removed. And you can see here, even tombstone, they want to have it with granite. Okay, it is a highly resistant material, and colored granites are very good to see. So that's why people use these things. Crushed stones. Usually, different types of igneous sedimentary and metamorphic rocks are crushed to small sizes and used in macadam roads and also as railroad ballasts. Stone chips are mixed thoroughly with Portland cement and form very good aggregates for the construction of buildings and paved roads and airstrips of the aerodromes. Crushed stones are also used as flux stones in the production of pig iron and steel. Crushed limestones are used extensively for the improvement of soil for agriculture purpose. There is a demand for utilization of crushed stones as road metal, as concrete aggregate, as railroad ballast, and for similar requirements. The best crushed materials are trap rocks. See, trap rocks means they are a rock called basalt. These type of rocks you will find a lot in Maharashtra, Gujarat, and also in northern part of Karnataka. That means about 70 million years back, there was a volcanic eruption in this region. So all the lava that poured out got solidified and it has become a rock called basalt. They are called as trap rocks because they show a step-like scenery there. So the best crusted materials, they are trap rocks, that means basalt and granites. The trap rocks include various types of rocks, particularly the dull color rocks with no mica or quartz. Because if mica is present, mica is a flaky mineral. Okay, it will reduce the hardness of the material. They are primarily dense, dark, and fine-grained igneous rocks of volcanic or plutonic in origin, such as basalt. I told you, basalt. that is found in the Maharashtra area, Gujarat, and also northern part of Karnataka. Dolerite, diabase, and andesite. These are all the rocks that are used as a crushed rock material. Granite rock includes coarse-grained materials with lighter color, such as true granite, syenite, and rhyolite. Coming to the metamorphic rocks, granite gneiss, quartzites, marbles, which are of great value to the crushed stone industry. Marble chips are utilized extensively for the tile industry, for chips industry, and also as concrete flooring ingredient. Thus, marble, it furnishes a large tonnage for different purposes in construction works. Quartzites means it is a rock. It is a metamorphic rock mainly made up of quartz grains. This is preferred as railroad ballast. That means on either side of the railway track, you can see the spread out of this stone material, crushed stone material. That is nothing but quartzite. And it is also a source of silica. It will have only quartz in it. Quartz is SiO2. So 99 to 98% SiO2 is recoverable from it. So that's why it is used in the manufacture of silica refractories and also in the glass industry. Sedimentary rocks, which are very massive, compact, and fine-grained, are considered as a source of crushed stone materials. Limestones, however, too soft and unsuitable for crushed rock industries. Sedimentary rocks are not hard and tough as igneous rocks, but they are utilized and highly regarded as structural material in concrete and in various types of highway constructions. Sandstones are preferred because of their toughness for different structural purposes. Some of the compact fine-grained sandstones possess a hardness and toughness which may be almost similar to the trap rocks. So that means this is as good as an igneous rock. Certain porous volcanic rocks are also used as a lightweight aggregate for building insulation. See what happens whenever there is an eruption of the volcano, lot of liquid will come out. Along with that, ashes also will come out. So those ashes, they will fall down onto the surface of the earth and they get consolidated and they form into a lightweight aggregate, a rock called pumice. Even if you put it in the water, it floats. Rock that floats. Okay, it won't sink, it floats. Okay, it is nothing but the ash of a volcanic eruption. So that is also used as a material for building insulation. You can see the crushed stones of different sizes. So rocks required for concrete and road metals, rocks of different types which are strong and durable are used for highway constructions. The crushed stones used in concrete depend largely upon kind of structure to be constructed. The chipped stones aggregates in concrete serves as a filling material, reducing the quantity of cement necessary per cubic meter of the area to be constructed. It is thus desirable that the coarse aggregate should occupy as great a volume of the concrete mass as possible, commensurate with the necessary degree of concrete workability. The maximum size of the coarse aggregate is determined on the basis of the design of the structure to be built. So, closely spaced reinforcing steel rods require rather small size aggregates, whereas massive mass concrete require coarse aggregates for the sake of economy. So, all these things are taken into consideration. Especially in the construction of highway and airstrips, the maximum size varies from 3.81 to 6.35 centimeter. So, aggregates should be tough enough to withstand the effects of atmospheric weathering agents. That is the most important thing. But these properties not very urgently necessary for unexposed structures. So stone chips are used for asphaltic concrete. They show variable result depending upon the affinity of the chips for the asphaltic materials. So acidic rock aggregates. Acidic rock means rock which contains more of silica. That means rock which contains more of quartz grains. Okay. They can be exposed for long time for water action. Asphaltic materials are gradually washed away and the aggregates are exposed to the surface, producing the angular and irregular rock fragments exposed on the road, which may cause damage to the wheels of the moving vehicles. The rocks of this type are known as hydrophilic and these rocks prefer water. On the other hand, dark colored basic rocks, I tell you rocks like a basalt, which show a better adhesion for asphaltic material are known as hydrophobic. Okay, so sometimes what happens, distinction is not very pronounced and clear, but it has been found that asphaltic aggregates produced with different types of rocks show different types of durability when exposed for a number of months under heavy monsoon condition in a tropical and moist country. Some additives are usually mixed with the common asphaltic material to improve the durability of the asphaltic aggregates in order to ensure a durable road surface or heavy vehicular traffic. So here you can see there is a mining area where the rocks are crushed and they are milled, they are floated to very fine grain size, and finally they are used for asphalting. Now, let us discuss the importance of sands other than glass sands. Okay, so a general classification of sand other than glass sands has been adopted on the basis of their mode of origin and economic uses. They are fluvial and lacustrine sands. Fluvial sands means river borne, river which brings the sand. Lacustrine means lake. In the lake itself, some sands are deposited. Windborne desert sands. In the desert regions, lot of sand material is available in the form of sand dunes. They are windborne desert sands. Mineral sands formed as marine placers, transported or residual sands. That means sands that you see in the beaches. So like that, different types of sands are available in nature and they are used in different industries. So they are used for many purposes: foundry purpose, filter beds, abrasive purpose, sand blasting, engine sand, sands for sheets asphalt and furnace sand, etc. So these sands, they are made up of silica material, that means quartz grain. Sand is nothing but quartz grain, but they are invariably very high in silica content, consisting chiefly of quartz grains. That is the composition of sand. So for a selection of filter sands, careful sizing is necessary. And for foundry sands, the bond is usually of clay substances or phyletic material. The same deposit may produce several grades of sands by appropriate methods of screening and proper washing. The sandy materials are usually derived from the disintegration of soft sandstones and decomposed quartzite. So that means when the rock is subjected for weathering, physical weathering or chemical weathering, whatever the minerals are there, some of them, they cannot withstand the weathering conditions. So they get dissolved in water. For example, imagine a river flowing on a rock body. Okay, so that flow, what happens, some of the minerals, they may get soluble in water itself. Some it cannot dissolve, or it cannot, it will not become part of the water. On the other hand, it remains separate. As a result, this will be carried. So from the source region, the angular material will be carried for a longer distance till the beach area where it becomes rounded. That's why in the beach area, you will get the rounded quartz grains only, not other minerals, because most of the minerals get dissolved during its journey, during this transportation. So these are all the sands. We have a river sand. So river sands are also there, and marine sands are also there, and also desert sands also are also there. And they are used for different purpose. Now let us discuss one by one these things. Foundry sand or molding sand, usually medium grain sand, which contains some binding materials such as clay, may be used as casting material in a metal foundry. Sands which are used for making mold is called molding sands, and those which are used for the cores are called core sand. So here, molding sands are usually bonded with bonding material, whereas core sands, they are bonded with oil or serial binders, resins, and pitch. The term sharp sand is used for foundry practice to indicate the sands which are free from bonds. The important properties that is required for a foundry sand are: texture should be good, that means alignment of the mineral grains, fineness, bonding strength, permeability, centering point, and durability. Grain size should be between 2 and 3 mm. So the grain should be subangular or angular or occasionally rounded. The finer the grains, the more will be the permeability and strength. This will control the metal casting to a considerable degree. So in different thickness, you will get these kinds of sands, and in the regular bedded deposits covered under the aluminium. So these sands, they occur as isolated pockets in older aluminium. That means if you take the flow of the river Ganga in the northern part of India, where you have thick aluminium, that aluminium contains these pockets of sands also, with different grades of materials in different pockets. Sands from dunes are sometimes used for core mixture. White, soft, and decomposed sandstones are sometimes used as foundry sand after careful washing. See here you can see the foundry sand, and this is the sand which can be molding sand. Filter sand. See, filter sand is used in the towns and cities for sand beds in order to purify the water so that suspended impurities can be removed, sediment and also bacteria from impure water or impure river or lake water. So what are the essential characteristics for the filter sand means? Uniformity in texture should be there. Sand grains should stand the water pressure very well, and they should not be disintegrated or dissolved in water. Impurity of limestone grains is considered harmful. Sand deposits of high silica content are usually selected by the municipalities or corporations as good sources of filter sand. So, okay, you should not, the soluble impurity should not be more than 2% in all, which may be dissolved by hydrochloric acid. So, the grading of filter sand depends on two factors, that is effective size and coefficient of uniformity. The size control carried out by sieving analysis and dry bases, we should be out. It should be about 10% as fine grained and 90% as coarse grained. Okay, grains should be 0.2 mm to 0.7 mm used as filter sand by usually waterworks. But the efficiency of filtration is much increased when the grain size varies between 0.35 mm and 0.65 mm. Any river or lake sand with high silica content or low soluble products may be used as a filter bed sand. So this is the filter sand that has been used here, and this is how the for filtration purpose how the stratification is done, and water inlet, raw water enters here and passes through porous closed sand of different sizes, gravel of different sizes, and in the water outlet it comes out with purified. Okay, it's a bed filtering, right? This is what is done nowadays. This is even for after digging a borehole, if you get a groundwater, surrounding 3 feet area will be made, and that will be with gravels, sand, and mosquito net, and also they would put some charcoal so that whatever the rainwater falls on the surface of the earth, it runs off and takes some unwanted material. When it enters into the ground where your borewell is located, it automatically filters and sends good quality water to the borewell. Next is abrasive sand. So this is used for grinding purpose, and for the manufacture of abrasive material, they are known as abrasive sands. Okay. Usually glass sands of medium texture which are free from impurities are preferred. Okay, they are used for sawing stones. So if you want to bring beauty to the gemstones, these abrasives are used. Grinding glass, sand blasting, and for the manufacture of sandpapers it is used. So unsorted sand is often employed, and marble slab manufacturing industry use clean washed river sand. Glass grinding sand should be avoided of very fine silt particles, and presence of clay is objectionable here. Clay matter should not be there. Okay, so in the normal course, sieving and other things are done to obtain the very good quality sand mesh. So sand blasting by means of air blast and blown against the surface to be abraded. So sharp grains containing angular and subangular quartz are usually selected as they are supposed to cut faster. Ordinary river sands with sharp grains are marketed for this purpose. Nowadays, very little naturally occurring sands are used for the manufacture of sandpapers. Artificial abrasives are usually preferred in the place of natural sandpaper. So here, this is a mineral garnet or corundum. If you crush and if you make it into a paper, so this is used as a sandpaper. This is a abrasive sand material that can be used. Engine sand or road sand, that means sand used to avoid slipping of engine wheels from the rail lanes, and also cars and trucks on the slippery roads. They are known as engine and road sand. Fine grained materials are usually preferred for this purpose. Rounded or sub-rounded grains with silica contents prove to be satisfactory. For railroad sand, high silica sand between 20 and 80 mesh paper to give good results, it is used. For road purpose, ordinary river sand is quite sufficient, but it should be strictly fine grained and free from angular quartz grains. Furnace sand, this is for lining a furnace bottoms and walls, in particularly in open hearth steel furnaces. This type of silica sand is used because the banding materials are plastic fire clays here. So very little bonding material is okay for this. So Preferably, common molding sands are preferred as they are almost analogous to the specification of furnace sand. So this is the sand that is used for the furnace. Building sand. River and lake sands are extensively used for constructional purposes. The materials from sand are screened and the coarser materials which are known as gravels are separated. So that's why for building purpose, always river sands are used, because river sands, they are angular in nature. Okay, they hold the cement very in a firm way compared to the rounded sands. So usually in the beach area, you will get the rounded sand, but along the river coast, you will get a very angular, subangular grains of the hard grains in the sand. So fine sand is ordinarily used as a concrete sand and also mortar sand, and sometimes for certain types of plastering work. This is the material of the building sand. So here you can see the difference between the M sand and river sand. Nowadays, people are using M sand because of the scarcity or improper mining of the regular sand. M sand means manufactured sand. Okay, this is done with the help of crushing the rock. You crush a rock. For example, you crush a rock which contains quartz grains in it. For example, granite. Granite can be crushed, or a nice rock can be crushed, and it can be made into a sand. This is what is known as a manufactured sand. Okay, you can see the difference. The difference is that this manufactured sand or M sand is good for wall concreting, but for a roof concreting, always river sand is good, because in the river sand you will have sub-rounded grains compared to the very much angular grains in the M sand. So that holds the concrete very nicely. Stowing sand. This is for packing wide areas in coal mines. After the removal of pillars in the coal mines, they put this kind of sand known as stowing sand. Okay, so you can see here de-pillaring with stowing sand. That means pillars are removed, and here will be replaced by the sand material. It's called stowing sand. Auriferous sand. Auriferous means gold containing sand. Some sands, they contain gold particles. Alluvial gold, it is called, maybe due to the movement of the water along the drainages, natural drainages, and also in the river course. So alluvial gold is found in sands of many Indian rivers. Draining areas of especially the oldest terrain like ours. Entire southern part of India is made up of oldest terrain. That means if you date the rocks of this terrain, they will give age in terms of 2,500 million years, 3,300 million years, like that. So, possessing proper gradients for the deposition of sand containing precious metals. Such conditions are found in many rivers of Deccan area, central India, and Chota Nagpur district of Bihar. Most of the peninsular India, they contain auriferous sand. So auriferous sand means you can see the gold in the sand material. Magnetite or ilmenite sands. They are very common black sands of the sea coast or a river bed containing ilmenite and magnetite, which can be separated easily by their magnetic properties. These types of magnetic sands are distributed widely in India. Okay, so that means river draining these rock formations, the rock will be flowing on a river. While flowing, it may take some minerals along with it. If the minerals are magnetite and ilmenite is present in the rock, it will take that also, and carry these disintegrated particles of heavy magnetic sand and deposit them either on the river beds or on the seashore, where the velocity of the stream water is reduced considerably. That means in the meandering areas where the river takes a turn, there the velocity of the river gets reduced. There, deposition of the materials of this sort can be observed. The important deposits of ilmenite sands are in the beaches of Kerala, in the east coast and west coast of India. In the Orissa, Tamil Nadu, Kerala, you can find this deposit, and it is a very important economic mineral. Nowadays, ilmenite is being mined throughout the coastal areas, which contain titanium up to 31.6%. So it may contain an admixture of isomorphous admixture of magnesium and occasionally manganese. So it forms a isomorphous series, in fact, FeTaO3, MgTaO3, and MnTaO3. Ilmenite, it is a source of titanium ore, so which is extensively used as a white pigment and also in the alloy with iron as ferrotitanium, which contains about 10% to 15% of titanium. The alloy has a high heat and corrosion resisting capacity. It has also a good welding capacity and low specific gravity. Titanium alloys are considered as an important material of the aircraft industry also. Titanium is also used as a brown pigment in ceramic technology and also as a radio wave detector. So all along the coastal regions in Kerala, Tamil Nadu, and commercial beach sands are found in Chavara, Manvalkurchi in Tamil Nadu. So they all contain TiO2 varying from 59% to 60% and also 54%. So heavy mineral content is also varies from less than 10% to as high as 65%. So surveys have been done, radiometric survey. That means taking a Geiger-Müller counter, they have surveyed these areas, and magnetic survey they have done. And they have found out, they have drilled such areas in the coastal regions, and up to some depth, they have found where this material along with the sand, that is heavy mineral sands, they are called heavy mineral sands, up to certain depth only. The concentration of these heavy mineral sand, like ilmenite or magnetite, as you go deeper and deeper, concentration diminishes. Okay, that means it is a shallow mineralization that is found in the coastal areas. So these are all the magnetite and ilmenite sands that have been recovered on the coastal areas.
Time up, sir.
Yes. So to conclude, construction, many other rock or mineral dependent industry cannot survive without the use of limestone, granite, basalt, schist, variety of sands, etc., etc. Hence, these rocks or minerals play a vital role in the development of the society. Okay. Thank you very much for listening to my lecture. So I have taken some additional time. Okay, so because I wanted to complete all these things, I wanted to give you information on the various industrial aspects of these rocks. Thank you.
Thank you, sir.
Okay. I hope if you have any queries, one or two, immediately I can answer. Because
there
next
is a question, sir.
Yes.
Sir, why only river sand can be used? Why not seashore sand?
Yeah, that is the thing. See, seashore sands are rounded because they have undergone a long transportation. So the grains will become rounded. They will not be adhesive. They cannot fix to the cement properly. Compared to the river sand. River sand means it will be more angular or subangular. So you don't find any rounded grains there. That is the advantage. Yes.
Thank you, sir.
That's why, though we have Thar desert, we cannot use that sand.
Yes, sir.
Yes, earlier it was part of a ocean, right? So you don't find angular grains there. Otherwise, we would have avoided this sand mining, sand mafia in our country. So we cannot do that. So that is the problem. Yes, please. Anything? Okay. Thank you very much, because the next speaker is waiting. I have eaten his time also. So thank you very much for bearing with me.